The semantics of spatial demonstratives. This presentation is co-authored by Mikkel Wallentin, myself, and Roberta Roca. We are from Aarhus University Hospital, and the University of Texas at Austin. Spatial demonstratives are really important in language. There are words like this and that in English, and these words are among the most frequently used words in spoken language. They're language universals. That means that there are spatial demonstratives in all of the world's languages. They're cornerstones in language acquisition. That is, that they're among the first words that children use, and they're used to coordinate the attention of our interlocutors. So if the child wants to get something, it could say this or that and point to it at the same time. So spatial demonstratives form a really interesting intersection between language and perception, or more generally between language and cognition. By the way, the results that I'm presenting today, they've recently been published in this paper, and you can find a link to the paper on the bottom of the page. So, demonstratives are used to point to things in the world. But might there also be more to the meaning of demonstratives? We previously investigated this by asking participants to read words. It could be the noun apple, and combine it with a demonstrative, either this or that. And what we found was across both Danish, Italian, and English was that a noun like apple would more often be combined with a proximal demonstrative, that is this, than a distal demonstrative. Whereas if we used a word like tiger, the opposite pattern emerged. We interpreted this to mean that manipulable objects, that is, objects that are small, inanimate, and harmless, evoke larger proportions of proximal demonstratives. So the idea being that we imagine interacting with the worlds when we combine nouns with demonstratives. But is that all there is to it? That's the question that we set out to investigate in this experiment. So the task of combining words with demonstratives, we've now called the demonstrative choice task. And it is as simple as I've already explained. You simply are presented with a word and combine it with either a this or that. In the current experiment, participants were shown 48 or 49 words each and asked to make a choice. They were informed that there are no correct responses and that they should just use their intuition. The whole procedure took approximately 4 to 5 minutes to complete. So you could do it on your phone. You would get an introductory screen like this, and then a word would appear. It could be testimony, and I would imagine that I would choose this for a testimony. I would continue. Then the word spaghetti came up, and for some reason I would choose that for this word and go on. And then the word editor came up, and obviously we all know that editors are really horrible, so I would say that editor and distance myself to the word a little bit. And what I've tried to illustrate with editor here is that I'm to some extent imagining myself in a relationship with the particular word, and I'm using that to make my choice. The words that we used in the experiment were words from the Binder database in a publication by Jeff Binder and colleagues from 2016. We used 506 of these words, and they're rated on 65 different semantic dimensions that you can see here on the x-axis in the plot, and a small portion of the words are on the y-axis. The words we chose were also rated in a recent publication on sensory motor features from Lancaster University, and we included 11 of those features as well. When we had these 76 semantic features, some of them are correlated, so therefore we did some dimensionality reduction. We used factor analysis for this, and we ended up with 12 factors: vision, valence, loudness, human, taste, smell, motion, manipulability, scene, time, torso legs, arousal, and self. And in parentheses here you can see how much variance each of these factors explained in the 76 dimensions. And on the right you can see word clouds of words from the database plotted according to how high they were rated on a example features, factors. Here's manipulability and valence, and I've highlighted the negative valence here. Participants in the study, which was approved by the local review board at Aarhus University, were 2,197 participants recruited through the website Prolific. They were native English speakers. They're a bit more female than male participants, but they had a wide age range. And here are then the results. The proportion of proximal and distal demonstratives in the data was roughly equal. 46% of choices were this, and 53% were that. And the standard deviation of proximal demonstratives across words was 0.114. Okay, this variance that the standard deviation indicates, is that random? That's the question. If participants choose to couple words with demonstratives at random, we would not expect to see any pattern in a split sample analysis. So that's what we did. We split the data into two halves, and we found for each word the proportion of this / that for each word, and correlated those with each other. And the null hypothesis here is that if choices are random, then this index for the two groups should be uncorrelated. So here's a plot of the proportion of proximal demonstratives in split 1 against the proportion in split 2. And as you can see, they're highly correlated. Each dot here represents a word, and on the right you see the green dots are those that have most often been coupled with a proximal demonstrative. So there are words like peace, spring, tea, morning, and joy, whereas words on the left are those that are most often coupled with a distal demonstrative, and they are words like riot, tornado, explosion, gunshot, and terrorist. And there's a Pearson correlation of 0.82 between the two splits. So here you have words often denoted with this, here you have words often denoted with that. And you can see that this pattern is highly reproducible. So we reject the null hypothesis. There is a pattern to this. Right. The question then is, what is that pattern? Does semantics play a role? And here we conducted a regression analysis. Again, we used the proportion of proximal demonstratives per word as dependent variable. We used the 12 semantic factors as independent variables and found that 10 of these actually significantly contributed to the choice of demonstrative. Those were valence, loudness, human, taste, smell, motion, manipulability, scene, time, arousal, and self. Some of these factors caused more distal demonstratives and some caused more proximal demonstratives. So here you have an example with loudness in the word cloud, and these are words that cause participants to choose that more often. And underneath you have self as a factor, and these are words that cause participants to choose a proximal demonstrative more often. Across the 10 factors, we can conduct a linear combination of regression coefficients and project that back to the original features. And that's what you see here, the original 76 features. And on the right in green, you see the features that are most active in causing participants to choose this. And on the left, you have the features that are most active in causing participants to choose that. And what you see is that there seems to be a lot of positive things on the right and a lot of negative things on the left. So demonstrative choice is influenced by multiple semantic dimensions, including spatial, bodily, and emotional features. However, interestingly, we find that features related to the experiential self, that's features such as need and pleasant and happy, dominate over features related to proximity and the physical self. So these are the features that would normally be thought to be more relevant to spatial demonstratives. So demonstratives may thus be used to signal the relationship between speakers and objects, not only within bodily self, but also in semantic hyperspace centered in the self. Further developments of this paradigm may reveal new practical applications, we hope. As I said, the paper has already been published. You can find it here. More importantly, you can also find all the data and scripts available at OSF. So look it up and see if we did the analysis properly. Thank you for your attention.